Everyone, welcome to the video where we will be finding the intervals of increase and decrease of some polynomial functions using our derivative. All right, so here's our step process for it, our four-step process, but we'll break it down as we go. So in this example, it says find the critical numbers. Then we'll find the open intervals where the function is increasing and the open intervals where the function is decreasing. Okay, so step one, we're going to find the derivative. Oh, let me use black ink instead of red. Okay, so we need to find the derivative. Okay, so the derivative, I'm just going to write derivative. Well, this one's pretty easy. We can just do f prime of x is 3x squared minus 3. And then once we have the derivative, it's usually best to factor it before anything else. So let's factor. Our f prime of x is 3 and then x squared minus 1. And then notice this factors. So f prime of x is 3x minus 1 times x plus 1. Okay, so this is going to be useful for us. I said to circle it. I usually actually cloud it. So we're going to use this for other things. But for now, I cloud it because it's a good way to view the reference. All right, so we found the derivative. Now, step two, we're going to set that equal to 0. So f prime of x equal to 0 means put this left side equal to 0. And then we'll solve. Well, regular old constants don't really matter. You could divide that out. So we could divide that out, and then we would have 0 equals x minus 1 times x plus 1. Okay, so let me add the note. So it's okay to divide out constants. So the 0 divided by 3 is okay to do. Okay and when I say divide out, I mean it's going away. Okay to divide out constants, but never divide out a variable. So if I were to divide, so I'm going to erase this, don't write this right here. This would be a mistake. So we're not allowed to eliminate variables like that. So that would make the variable disappear, but that's breaking some of the rules for our math because, well, x could be -1, and if x is -1, then you'd have 0 divided by 0, which is undefined. Okay, so anyway, so be careful of that. So it's okay to divide out constants, never divide out variables though. Okay, so it's okay to divide variables in some cases, but don't divide it out with 0. So let's write this. So never divide 0, let's say it like that, 0 by a variable. Let's fix that language. So never divide 0 by a variable. Okay, anyway, so that's now that's fixed. And then now that we have this set up, though, we will just use our 0 product rule, where I can set this equal to 0, and then this equal to 0. And then while each of these is easy to solve, I'm going to put my answer up top here. So for number 2, we add 1, we get x is 1. Subtract 1, we get x is -1. Okay, so these are the critical numbers. So if they ask for it in your problem, well, there they are. So you could just tell them x equals -1 and +1. Okay, so those are the critical numbers. Now, step 3, it says make a horizontal number line and plot only the critical numbers. Okay, so, and let's leave a little space here. So 3 is our number line. And make sure they're in the right order. So -1 is smaller than 1, so it should be on the left. Notice I'm not putting 0. I'm just plotting the 2 numbers that I found as my critical numbers. All right, and then now that I have these, what I need to do is test values that are in between these intervals. So anything bigger than 1, anything in between -1 and 1, and anything less than -1 into our function, into our derivative function. Okay, so the way that I usually set this up, let's put x, so these are x values, and then we're going to put f prime, and then let me put this in red, f. All right, so all I want to do is figure out the signs of f prime. Okay, so I'm looking for the sign, so I'm going to test values. So we're going to test x equals, so anything bigger than 1. You could choose whatever you want. Okay, so I'm just going to choose 10. So that's bigger than 1. And then we're going to plug it into our derivative. So f prime of that, so that's why we circled it, because now I'm using it again. So f prime of 10 is 3 times 10 minus 1, let's just say that's 9, and 10 plus 1, which would be 11. Now, all we care about is the sign to these things. 3 times 9 times 11, that's all positive, so you don't have to calculate it all the way if you don't want to. Here, I'm just going to say, hey, these three numbers multiplied is positive, so f prime of 10 is positive. So usually what we do is we just show a little plus in this interval where we used x equals 10. Now, it would be true if you use any other number, if any other number bigger than 1. So if you use 2, 3, 4, 5, 6, whatever, it would always tell us that this derivative is positive in this interval. And so we just put a little plus there. And then we just go through and keep doing it to the other intervals. So anything between -1 and 1, I'm going to use x equals 0. And so we plug it into our derivative. So f prime of 0 is 3 times 0 minus 1 is -1. So I have 3 times -1. 0 plus 1 is 1. Again, a little tight on the room there. So that is f prime of 0 equals 3 times -1 plus times 1. And, well, positive 3 times -1 times positive 1, that would be a negative. So f prime of 0 is negative. So that means we usually put a little negative symbol there. And then let's do our last one. So anything left of -1, let's use x equals -10. I usually like to use anything that has a 0 in it if possible. Okay, so again, you could choose any value that you want left of -1. But when we plug that in, so f prime of -10 would be 3. -10 times -10 minus 1, is -11. And then -10 plus 1 would be -9. Well, again, you could get the actual number if you want to, but all I care about is the sign, and I see, well, a -11, and that looks like it's positive 1. Let me rewrite that. There we go. Okay, so a -11 times a -9 would be positive, times 3 would be positive. So this is also positive, like the end one there. So this is positive here. Okay, and then now what I have is wherever f prime is positive, I know f is increasing. Okay, and I usually just use arrows, but this is telling me increase. Wherever f prime is negative, my f would be decreasing. And then wherever f prime is positive, again, is still where it would be increasing. And there we are. Okay, so now we have our answer. So it increases. Let's abbreviate increasing as INCR. So it increases on the interval, well, everything left of -1, so that means -infinity to -1. And then also it increases from 1 and then to the right forever, so 1 to infinity. And then it also decreases just in one interval from -1 to +1. There we go. Okay, so there's our two answers for the part that they wanted there. So I already had the critical numbers. And now what I want to do, so since we could use a calculator, so if that's allowed, and often it is, I'm just going to set up my calculator. There it finally is. Okay, and I don't really want scientific. I want to graph it. So you can graph all of these to check. Okay, so I want to graph x cubed minus 3x plus 4. And then let's see the graph. It looks like this. Let's get the projector. Okay, so it looks like it is increasing. It's going up from left to right until -1 is where the peak is. And then it decreases until that peak of +1. And then afterwards it increases again. So that matches what we had. Okay, so we're doing it the calculus way. The calculator obviously is much faster, but still it's good practice to do it with a calculator, all right? So, or with by hand with calculus. I would say be able to do them both. Just check real quick in a calculator, but make sure your calculus skills are good. Okay, so anyway, so let's do one other. So let's take a look at this. Okay, and this also might help Okay, so these were nice numbers, the -1 and the +1, where that ended. Sometimes they're really weird numbers, and they might want an exact value. So say it's like the square root of 17. Well, the calculator would only show a decimal, so we might not know what that actual answer is, whereas the way by hand would definitely give us the exact answer that they want. Okay, and then we could check by changing it into a decimal and verifying with our graph.